Good morning, class. Welcome to St. Peter's School. This is your science class, and this is our fifth class. So, in previous class, we have been discussed up to the what is velocity and what is the rate of change of velocity. If the velocity is changing in a uniform way, it is known as a uniform velocity, and if the body is moving in a non-uniform motion, then the body is covering the body is in a like speed is in non-uniform, and as well as the velocity is also a non-uniform. So okay, now before starting the class, I would request all the students, please take out your books and keep in front of you, take out page number 4. Okay, so we have discussed about this table for given at the top of this page, that is uniform and non-uniform linear motion. Let's have a very quick revise. We have seen in the table that armor is only covering the uniform. Armor is also only moving in a uniform motion, because that there is a time interval is fixed, but there is a distance covered by the armor is also and the interval is fixed, but distance covering by Akbar or the distance covering by Anthony is not fixed by the interval of time. उनका जो है चलने की जो speed है, like you can say, they are not covering and the distance at a equal interval. For example, Amar is covering at a 5 second, it covers only zero. So after 5:30 it covers 20 kilometer. After 6 there is a 40 kilometer he covers. So there is a difference of 30 minutes in the time also, and there is a difference of 20 minutes in their distance also. But with the Akbar, time is fixed, but the distance is not fixed. There is a no constant changing of distance covering, so that will be considered as a non-uniform motion. So the first point you will see in the slide, it is written here: when the velocity of an object changes at a uniform rate. Okay, so when velocity will be changed, like if the body is covering if the body is moving with a uniform motion, it means it is moving in a uniform speed, and it is moving in a uniform velocity also, because we already discussed this point that velocity is nothing, it is a speed only moving in a definite direction. So body is here moving in a definite direction, so it's a velocity. So if the body is moving in a uniform motion, then body is it is be considered as the body's velocity is changing in a uniform way, that is uniform velocity. Okay, then average velocity is given by the arithmetic mean of initial velocity and final velocity for a given period of time, that is average velocity. Okay, now what happens, like a body is moving with a uniform rate, so velocity is also changing with a uniform rate. But why we are why we are discussing this point that velocity is also calculated as average velocity, but because we discuss about that bike case, when when the bike used to turn the bike was taking a turn. So at that time, what we consider that he was changing the direction, so the velocity becomes zero at that time, and because the direction was changed, but body is still in motion. So what we will do, we will consider a different initial velocity we will take of the body, and we will consider the final velocity of the body, and we can take the average velocity in that case. If the body is moving direction again and again, but with a equal interval, 5 kilometer is going, and again he is turning the direction, again he is going for the another 10 kilometer, and again after that he is going for 15 kilometers. So there is a equal changing in the interval of the speed, or equal change and changing in the distance they are covering at a equal interval. So in that case, what we will can do, we will take up previous velocity of the body, and we will take the final velocity of the body, and we can take out the average velocity in that case, where u is the initial velocity of the object, and v is the final velocity of the object. Now, what we studied about the velocity, there is a concept given here: velocity. Velocity can be changed by changed by the changing the speed and direction of the body. Yes, that's why we are considering here the मुझे हमें एवरेज वेलोसिटी इसलिए निकालना पड़ता है कि बिकॉज इफ द बॉडी इज चेंजिंग द डायरेक्शन, इट मीन्स एट दैट पॉइंट वेलोसिटी ऑफ द बॉडी विल बी जीरो. Okay, again the new velocity will be there, and then another final velocity will be there. So that's why average, what we can do every time we can take out the average velocity, and then we can add this. So velocity is a vector quantity. We are studying from the last two class that velocity is a vector quantity. Uniform velocity equal distance in equal interval of time. We I think you all have understood this. What is uniform velocity? What is uniform speed, or what like a body is moving in a uniform way? It means uniform speed or uniform velocity. Non-uniform speed means unequal distance in equal interval of time. Okay, that is covering by the Anthony. Anthony is covering unequal distance in a equal interval of time. That will be considered as a non-uniform speed. Displacement produced per unit time. Okay, displacement per unit time. What is the SI unit of the velocity? It will be displacement occurs per unit time. Has magnitude, that's why it is considered as a vector quantity, and the direction of velocity is same as the direction of displacement of the body. Okay, now move to the next point that is given in your book, acceleration. Okay, so now what is the acceleration? Acceleration is nothing when the velocity of an object changes, it is said to be an accelerating. Okay, like we have seen in the case of bike. For example, when he is turning the bike, he is changing with a different speed with increasing the velocity or increasing the speed. Okay, so that is called accelerating. So acceleration is the rate of change of velocity with the time. Okay, and you can see in your book there is one example given here. Take a 1 meter long plastic tube and cut it in lengthwise into two halves. Take one of the channel, shape it pieces, place one of its ends on the ground and hold the other at some height from the it means that you are making a inclined plane. You have seen slide, so you have to hold that plastic tube in that way, in the slide way. Okay, take a small ball and release it from the upper end to the of the channel. Now you are, what you are doing, you are taking a ball and from the top you are take a small ball and release it from the upper end of the channel. From the top you are releasing the ball. Okay, so observe the velocity of the ball as it rolls down along the channel. It is velocity the same at all points. Observe, is its velocity same at all points? This is the question here. Like from when we will see that okay, how the ball is going on the slide, we will so is it in the moving like that, the velocity is every same everywhere. Observe how the velocity changes as it moves from the top through the middle and to the bottom. Okay, you must have all played on a slide in a park. You know that while sliding down, the velocity is less at the top, it increases in the middle and becomes zero towards the end. Okay, what happens when we starting sliding? When we sit at the top and we started, then the at that time the speed is very slow. But when we comes to the middle of the slide, it increased. Yes, and when we reached at the end, and the velocity becomes zero. The rate of change of velocity is called the acceleration. So what is the velocity is changing for the three times in the same direction. So this type of velocity changing every the rate of change of velocity is called acceleration. Acceleration is nothing, it's the rate of change of velocity. Any change in the velocity of an object results in an acceleration. If the speed is increasing, we all say that the body is accelerating. But when when the speed of the body is decreasing, we all say that it is deceleration or retardation, or the change in direction called the centripetal acceleration. We will study about this, what is centripetal acceleration. Okay, now next point is given here. Much like velocity, there are two kinds of acceleration. Okay, average and instantaneous. What is instantaneous means? Like instantaneous, the term itself defines that it happens suddenly, right? So okay, so two kinds of acceleration is there, average and instantaneous. Average acceleration is determined over a long time interval. Okay, so average, where we all know that where we need to calculate the average, if something is happening again and again with that same interval, then in that case we can calculate the average of something, like if the speed is changing again and again by the equal interval, so we can calculate their average speed. If the body is changing with a different velocity at a same interval, so we can calculate average velocity. Now so in now is the same thing is written here. Average acceleration is determined over a long time interval. The word long in this context means finite, something with a beginning and an end. Okay, we all know that average is found only where there is a beginning, there is an end. Okay, the velocity at the beginning of it, this interval is called the initial velocity, represented by the symbol u, and the velocity at the end is called the final velocity. We studied about this point in the, like, when we have to find the average velocity. In that case also we search for the initial velocity of the body and final velocity of the body. Okay, so average acceleration is a quantity calculated from two velocity measurements. Acceleration is equal to v minus u by t. Okay, when we will find out the average velocity, then in that case what we will do, we will take the initial velocity and final velocity. Okay, and final value, and we will do plus those v plus u by 2. Okay, but in the case of acceleration, acceleration is what is, it is a rate of change of velocity. So here also we will take a initial velocity and final velocity, but we will divide it by the time interval, not by the 2, because there we are finding just the average velocity, but here we are finding the rate of change of velocity. So what will the formula? It's a final minus initial by t, v minus u by t, where a is acceleration, v is final velocity, u is initial velocity, and t is time taken by the body to move to, okay, so a horizontal line, a slope of 0, indicates that the object has zero acceleration and is moving at constant velocity. And we can easily understand by this, when the body stops, we already discussed about this point, that when the body stops, its velocity is 0, right? So its velocity is 0, so that's why if the velocity is 0, the acceleration will also a 0 and is moving at a constant velocity. Okay, so and in next class again, okay, so before moving the next class, if acceleration is in the direction of velocity, then it is positive acceleration. Sorry, I left this point with to discuss with you. If acceleration is in the direction of the velocity, then it is positive acceleration, and if it is in the direction of opposite to the direction of velocity, then it is negative, and the negative acceleration is termed as retardation. Now I know that most of you have not understand this what I have written here. So how it happens, like if the acceleration is nothing, we know that it's a rate of change of velocity. How it is possible that acceleration goes in opposite direction of velocity? So it means like that body is, suppose body is moving, okay, with starting with a very slow speed. Okay, so it will increase for some time, okay, and then it is increasing, that it means like it is a positive acceleration, the body's rate, like acceleration is increasing, rate of change of velocity is increasing, so it is a like positive acceleration. But suppose if the body is now moving with a lesser speed, lesser velocity, okay, it's decreasing its body, speed movement of the body, it's decreasing, speed of the body is decreasing, velocity of the body is decreasing, it means acceleration goes in a negative. Okay, and the negative acceleration is termed as a retardation, and the SI unit for the acceleration, it will be meter per second square. Okay. Okay, so you can see in the your books also, when an object can have a positive or negative acceleration. When the velocity of an object increases, the acceleration is positive. In this case, the acceleration is in the direction of velocity. When the velocity of an object decreases with the time, it has negative acceleration. Negative acceleration is also called deceleration. Its direction is opposite. So it's the same things written, which I have already explained it to you. Okay, so now in next class we will discuss about the distance time graph for the uniform motion and what distance time graph for the non-uniform motion. We will discuss about then these two in next class. Till the time, what you are going to do, you are going to keep revising all the terms. Still now we have completed speed, what is distance, what is displacement, what is speed, velocity, and what is uniform motion, what is non-uniform motion, what is acceleration, what is positive acceleration, what is negative. So you have to note down a proper, you have to make a proper notes on your notebook with the help of my videos, with the help of the points given in your book. And you can just click a photo of your notebook and you can send it to your sir. I can see, I will recheck your notes, and then you can learn those points. Okay, so we will meet in a second, like next class. Until the time, take care and bye bye.